to Programming for the Humanities and the Social Sciences. My name, if you haven't met me already, is Melody Beals. I want to begin with sort of what are the aims for this workshop series. Now, first of all, this is not a single workshop. You're not going to be able to leave here at 6 o'clock knowing everything you need to know about Python. You will have the basics by the time you leave here in an hour. But really, this is something I'm going to be holding every week. I'm going to be videoing them and putting the materials up online in the same place, so if you miss a week, if you're teaching, you just don't feel like coming in on Tuesday, that's absolutely fine. You can catch up and join us when you want to. But the aims of the series as a whole, first of all, is to introduce you to some of the core concepts in programming. And I do mean that in very much the wider sense of the term programming. So we're going to be learning Python this semester, but these should translate into R, C++, any other kind of programming language you're wanting to use as part of your research or just because you want to learn programming. I also really want to explore the value of programming and learning how to program yourself in the humanities and the social sciences. I'm going to teach you the basics of Python programming language. In the second semester, I'll probably be teaching C++, and I really like C++. It's sort of my primary coding language, and that's because it can do a lot of really chunky programming very, very quickly, but it's not necessarily needed for every single thing that you're going to be doing, and also there are a lot of existing libraries and programs in Python that you're probably wanting to use as tools. So it's really helpful to learn Python first so you can have access to all of those tools that are already out there. And then if you're developing your own thing, sort of bespoke programming, C++ could help you as well. But that's for January onward. I want to introduce you to some of the key libraries. The libraries are the tools or the sort of extensions onto the basic programming that I'll be teaching you that will give you the ability to do really interesting text analysis, image analysis, visualizations, and statistics. There's a whole host of other things that these libraries can do as well, but those are the basic ones I'm going to sort of be introducing you to that you can play around with to see how they apply to your research. And most importantly, I think I wanted to provide a weekly space for collaboration and intellectual growth. It's really heartening to see that there is a variety of different individuals here. They're not all from the same department or the same background and discipline. So hopefully this will give us a chance to talk, to share ideas, and let each other know what we're doing with these or just what we're doing in general. Who am I and what gives me the right to teach this workshop? Well, first of all, I am a lecturer in digital history. And what that basically means is that I am a historian who uses computation in order to carry out my research. I'm not a researcher in computer history or the history of digital things. I just use digital things in my research. I was trained as an intellectual and cultural historian, so my formal undergraduate and postgraduate training was along those lines. However, I'm an autodidactic, meaning I taught myself, social and economic history, so statistics and statistical models, as well as programming. So what does this mean about this workshop? Well, I'm not a computer scientist. What I mean is I'm not interested in computer science research questions. There's some really fantastic work going on across the street in the computer science department, and I would encourage you to look into it. However, what I'm interested in is using existing languages, existing tools, and largely existing methods in order to apply those to humanities and social science questions. So we might end up using tools in ways that they totally didn't expect us to use them, but we're not necessarily pushing things forward in computer science research. We're leveraging it for history, humanities, and social sciences. Just to give you a little bit more about my background, I have been programming on and off for about 8 years. I started off with a little bit of Python, or actually, I started doing some computer work when I was a small child and nearly destroyed my father's computer about 60 times, but he's forgiven me since. But I've done actual programming for about 10 years, first with Python and then moving into C and C++ and kind of going back and forth. I've done a little bit with R, so if anyone is interested in doing R programming with statistics, I can point you in the right direction, but it's not my field of expertise. So, with that very long preamble, let's get started. If you could all go to this website, tinyurl.com/Loughborough-P4HSS, Programming for Humanities and Social Sciences. It will bring you to a research notebook page. Now, at some point in our workshop, or in some point in your later career, you might want to download Python directly for your computer, but because I expected and was correct in expecting a variety of Linux, Windows, and Macintosh machines, I didn't want to spend 2 workshops installing Python with everybody. We're going to be using a cloud platform, which is called Microsoft Azure. They host Jupyter Notebooks, and Jupyter Notebooks are a way of prototyping Python programming code as well as documenting what you're doing. It's a really nice mix of essentially a text editor and a programming compiler at the same time. So when you get there, you should see 2 files, a README, which is blank at the moment, and an introduction, IPYNB, which is an IPython notebook extension. Now, I would like for you to clone or make a copy of this on your own account. Now, you will need an account in order to do this, but fortunately, if everyone here is a member of the university, you have an account because it's just your Microsoft Loughborough account. So if you hit the clone button, it will ask you to sign in, and you just sign in with your normal Microsoft account in order to get into it. So this is yours. They are public unless you unclicked public, but no one will be able to find it unless you give them the URL, and you can change the permissions on it later if you want. We're not doing anything particularly sensitive today, so I don't think it would matter if somebody found it. So if you all click on the introduction, iNotebook, and it should take you to this. This is what a Jupyter Notebook looks like. If you want to get this offline, if you want to be able to do this sort of thing on your PC, you can download and install Jupyter Notebook individually. There is a website that allows you to do it, but basically what you need to remember is that it is Jupyter with a Y, and that way you'll be able to Google it and find it pretty easily. And it's available on Mac, Linux, PC, what have you. Now, as I said, the nice thing about a Jupyter Notebook is it lets you document as you code. So if you want to write a little bit of code that does something, and then have a teeny tiny text file that explains what you just did, traditionally in programming, you would put a comment in. So you would put in a little bit of code that the computer didn't run, but that you could see. But this, because it's in a language called Markdown, lets you make it a little bit more pretty, we'll say. So that's why I'm able to have headings and italics and things like that. If you click on it, you can see it's still written in just plain text, in Markdown language, but this lets me do it this way. Each of these boxes in a Jupyter Notebook has the ability to run the programming code that's within it. Now, the most important thing you need to remember about Python is that Python is not compiled and then run the way that some other languages are. So it is run little by little as it goes down the lines, bit by bit. Now, this doesn't mean you can't do something called object-oriented programming, where you have many different files pulling bits of code back and forth. You can do that in Python, but for the purposes of the Jupyter Notebook, we're going to be doing very simple, straightforward, linear programming. And that means that if you write something at the top, you have to run it if something at the bottom is going to need that later on. So it's important that if I tell you to run a bit of programming code, that you do it. If you try to run a later bit and you've not run the top bit, it won't have the information it needs to continue. It has to go line by line throughout it. Does that make sense to everybody? Okay. So, the first thing I want to do is to welcome you to the notebook. And in this first box, I've written up a very, very simple bit of programming code, just so that you can get a sense of what it looks like and what it can do on a very simple level. So if you click on this box so that it turns green, and then you hit run up at the top of your screen, it will run this bit of programming code. And it should ask you a question. Go ahead and ask the question and hit enter. And you'll be asked a couple of different questions, and just go ahead and answer all of those. If I go here and I type in my name, I work in history, I belong to police, message. And this is probably the simplest program I could have written for you. It basically takes in some text inputs, rearranges them, and then gives you a text output. So let's have a little look at what I wrote here and see if you guys can figure out what I've done. So the first line of this is name equals input, what is your name? So what do you think is going on here? What am I doing? Absolutely, and why did I put name? Yes, very good. So it is basically the name of the field. It is for what we're going to call a variable. So this bit of programming code takes in 4 variables that I've named name, discipline, department, and rank. I did spend about 5 minutes thinking about what to call that variable. Rank seems a little bit archaic, but we're going to go with it. And then I had a print command. Now print, in this particular case, just means display in the console. And this little bit down here, where all this text appeared, is the console. If I were running one giant program, it would just have one console at the bottom where all of my text would appear. But because we've separated out, it's going to be little text boxes throughout this notebook. So we're going to go through all of these steps in a moment in more detail, but that's the basic idea of what this is. So, what we've done so far is something called assigning variables. Now, it's really important that you realize that there are some things that are different in programming than you probably remember from mathematics or that make sense to you as a human being. If you use an equal sign, it does not mean equals. It doesn't mean equals in the way you probably mean equals. What it means is a sign. So it means equals in that I want A to have the value of B. It's equaling B. But it's not asking, is A the same as B, the way it would in a mathematics question. If you want to know if it's actually the same as, you have to do 2 equal signs, in which case this would be false, because these 2 things are not the same on both sides. And this lovely little guy, exclamation point followed by an equal sign, means not equals. And that's a pretty straightforward, those are the 3 ones you have. You also have the basic ideas of lesser than or greater than, lesser than equals, greater than and equals. These are basic things that you will need to know. And this works just as importantly for text as it does for numbers. So if you're looking for all the fields that have a certain person's name in it, you will need to ask it to look for any name that equals a certain name. That's the sort of mathematical notation. But the one we're most interested in right now is just a sign. I would like this variable to be called this. Now, what a variable is basically a bit of storage. If you want to put in a value, store it somewhere for a minute, and then call it again later, like we did with our what is your name is this function, you need to put it somewhere. And that place is called a variable. Now, you can call your variable pretty much anything you want to. If you try to name a variable something that is a protected name, such as bool, it will turn green. And it will basically be telling you, no. We think bool means something important. It's part of the programming language. If you try to name a variable that, it's not going to work. So always make sure that your variables are black when you name them. Or if you're using them in Jupyter Notebook, obviously if you do this in just a text editor, you're going to have to just remember. The thing about what they can be equal to, however, is slightly more complicated. Now there's lots of different variable types. There are 6 that you'll probably come in contact with, and there's 4 that you probably will regularly come in contact with. The first one, the one that everyone loves, is a string, which gets abbreviated to str. And a string is anything that you want, basically. It can be numbers, it can be letters, it can be words, spaces, symbols. It is a literal string of characters. So anytime you're using text, that's probably what you're going to be using. A bool, like Boolean logic, is true true or false. And this can be really useful because the way that a bool is stored is just a 0 for no and a 1 for yes. So you can have a lot of data in a very, very small space if you're just going 0, 0, 0, 1, 1, 0, 0, 0, 1, 1, saying yes or no to certain questions. It also really greatly limits what people can accidentally input if they can't spell false for some reason. An int, or an integer, is a whole number. And in this case, in Python, what an int is a signed integer, which means it's negative infinity, well, we'll say negative a million to positive a million. And what that means basically is that you have to tell it if it's a positive or a negative number, but it's also a whole number. The next one is a long, which is a long integer, which means that it has a significantly longer number of decimal places or unit places. And the precise number for that is based on how much space it actually gets held in a bit. It's not actually when you get to 999, it goes over to the other side. In most cases, you will not need to use long integers, but if you find that your numbers are not working, or if you feel you're going to be using very large numbers in the millions, or tens of millions, or 20s of millions, and then you're going to suddenly be multiplying those, a long integer might be the way to go. A float is a floating point real value, which basically means a decimal number. So if you're going to have a decimal or a fraction, you should use a float. This is really important. If you say something is an integer, and then you say it's 2 divided by 3, it's going to end up being 0, because it's going to just say the next number, the whole number that it's closest to. So it's going to round for you, and you do not want to round if you're doing statistics, unless you want to get that value appears. And finally, complex for complex numbers, which I don't typically use in my research, but some of you who are a little bit more statistically minded might end up using complex numbers. Now, Python is a helpful language in that it will usually guess, and it will usually guess correctly, what type of variable you want. So for all the ones I did above, I didn't tell it was a string, but because it was a string of numbers and letters, it guessed I was a string and it treated it as a string. However, it's really good practice to actually say what you want it to be. So in this case, putting the str and then everything else in parentheses, in brackets, lets it know that name is definitely a string. Now the most common example of this is that if you have a number, like 47, and you want it in a string, Python is going to assume you want it to be an integer, and then when you try to treat it like a string later, it'll get angry at you. So it's better that if you know that you're going to have to do text or string-like things to it, to tell it it's a string from the beginning. Now I just gave you loads of information, and we're going to see how well that got processed, and we're going to help you through anything that didn't. So, what I would like you to do is in this run box below all of this, I would like you to create 3 different variables. I would like you to create a string variable, you can name it whatever you like, a bool variable, and an integer variable. And the things that you need to remember about these things is that strings must be in speech marks. It doesn't matter if you use double quotation marks or single quotation marks, but you have to be consistent. And if you want to have quotation marks inside, just like if you were writing an article, double quotation marks on the outside, single quotation marks on the inside, or vice versa. Again, just be consistent and Python won't get angry with you. A bool can have a value of either true or false in quotation marks, or of 1 and 0. So 0 for false, 1 for true. And an integer, you just put the number, equals 7. No quotation marks, nothing like that. So I'm going to give you a minute or so, see if you can create 3 variables. Write 3 variables in here and then run it. Or, what's even easier is hit Control-Enter, and that will automatically run the box that you're in. So, if I do my string equals melody, my bool equals true, and my int equals 4, and I'm doing very bad form here, so I'll do it correctly. also do things that you didn't know it was doing if you rely on its forgiveness. It's like a human being, if you give them kind of like vague instructions, you might get the right groceries, or you might get something you really don't want for dinner. So, now, if you hit enter and a number just pops back up on the line number, that's great. Is anybody stuck with a little asterisk there? If you run this box where it says I in and then a bracket, if it's a number, it means it's run and it's successfully run. If it's stuck on an asterisk, it means that it's thinking, and I might need to come and help you.
It was at this stage that my camera ran out of battery. So instead, let's continue with the screencast of the rest of Workshop 1. The first thing we're going to talk about is lists. Now, a list is a container, something to hold multiple variables in. So in the run box, we create a new variable, myList, and within square brackets we put in our 3 variables, myString, myBool, and myInt, separated by commas, and then run that box. Now if we go to the next and type in print brackets myList, we should have all 3 of our variables returned to us. Now let's do something with those variables, some basic operations, such as addition, subtraction, and so on. So to do this, we need to create a new integer variable, which we'll call newInt, and set as a value of myInt, our old int, plus 2. We'll then print what the value of our new int is, and look, it's 9. 7 plus 2 is 9. The great thing about Python and Jupyter Notebook is you don't even have to really create variables. You can use it essentially like a calculator. So 5 plus 3 equals 8. You can also do operations on strings. So for example, if we create a new string called beals, and then we print myString and add beals, or new string to it, we get melody beals, which is a single word because we didn't put in a space. So this time we're going to write print myString plus a new string with a space in it, and then plus new string, which is beals. And look, we get my name with a space in the correct spot. Now, what if we try to do something else? What if we try to subtract rather than add? Well, let's see, myString minus new string. And we get an error because you can't subtract one word from another. Instead, what the addition sign means is concatenation. So we'll end it there for today, but let's wrap up with looking at what we succeeded at doing. First, we learned about 6 different types of variables. We also learned how to assign and print stored variables. We also learned how to store our data in lists or containers. We learned how to do basic operations on numbers and basic operations on strings. That's it for today. I'll see you next week.